For most of human history, Saturn was a planet with just a handful of known companions. By the turn of the 21st century, that number had grown to a few dozen. But in just the last few years, astronomers have been in a race to count a flood of new discoveries. Today, Saturn has retaken the lead from Jupiter as the planet with the most known moons. As of early 2024, the official tally stands at a jaw-dropping 146. This isn't just a new high score in some planetary contest. It's a clue that helps us unravel a much deeper mystery, not just how many moons Saturn has, but why this majestic giant became the ultimate moon collector. If that number, 146, sounds shockingly high, you're not wrong. It's more than any other planet in our solar system. And if you feel like you've heard different numbers before, you probably have. The count is a moving target. In early 2023, the number was just 83. Then, in May of 2023, it leapt to 145 after astronomers confirmed 62 new moons at once. This constant state of revision presents a fascinating puzzle. Is Saturn creating new moons? Are they just appearing out of nowhere? The truth is, these moons have likely been there for millions, if not billions, of years. We're only just now finding them. And that leads to the much bigger question: what is it about Saturn that allowed it to build such a vast and diverse family of satellites? The short answer involves immense gravity, a chaotic past, and our own rapidly improving technology. But the real story is far more complex and interesting than just a numbers game. It's a story about cosmic history, violent collisions, and the very definition of what a moon is. To understand why Saturn is the undisputed king of moons, we have to look back in time, zoom in on the technology, and decode the strange orbits of these newfound worlds. A tale of two families. When we picture a moon, we usually think of something like our own, a large, round sphere in a predictable, stable orbit. And Saturn certainly has moons like that. These are its regular moons. They include the colossal Titan, which is larger than the planet Mercury and has its own thick, Earth-like atmosphere. There's also the icy Enceladus, famously erupting with geysers of water from a subsurface ocean, and the two-toned Iapetus with its mysterious equatorial ridge. These are the moons we've known about the longest, discovered by pioneers like Christian Huygens and Giovanni Cassini centuries ago, and later visited by the Voyager spacecraft. There are 24 of these regular satellites. They generally have prograde orbits, meaning they travel in the same direction as Saturn's rotation, and orbit close to the planet's equatorial plane. It's believed these moons formed right alongside Saturn from a swirling disk of gas and dust, like a mini solar system. But these 24 moons are just a small fraction of the total. The other 122 are a completely different breed. These are the irregular moons, and they are the reason Saturn's moon count has exploded. Unlike their orderly siblings, these moons are cosmic rebels. They are typically small, just a few kilometers across, and often shaped more like potatoes than spheres. Their orbits are large, highly elliptical, and steeply inclined. Many of them even orbit backwards, in what's known as a retrograde motion. These bizarre characteristics are dead giveaways that these moons were not born with Saturn. They are captured wanderers. Astronomers believe they were once asteroids or other small bodies orbiting the Sun. During the chaotic early days of the solar system, they strayed too close to the gas giant and were ensnared by its immense gravitational pull. So, Saturn's moon system isn't one big happy family, it's two distinct groups. One is a small, orderly household of native-born children, and the other is a sprawling, chaotic collection of adopted strays. Understanding this distinction is the first key to solving the mystery of Saturn's immense moon count. How to find a needle in a cosmic haystack. So if these hundreds of tiny, irregular moons have been there all along, why are we only finding them now? The simple answer is that our tools finally got good enough. For decades, a moon named Phoebe, discovered in 1898, was Saturn's only known irregular moon. Then, starting around the year 2000, new discoveries began to trickle in. But the real floodgates opened thanks to a clever technique called shift and stack. Imagine trying to take a picture of a single firefly in a dark forest. A quick snapshot won't capture enough light. But if you try a long exposure, the firefly's movement just creates a blurry streak. The shift and stack method solves this. Astronomers take a series of sequential images, tracking the predicted path of a potential moon. Then, software shifts each image to keep the moving object aligned. When these images are stacked on top of one another, the faint light of the tiny moon adds up, while the background stars, which have been shifted out of alignment, fade away. Suddenly, an object that was too faint to be seen in any single image becomes clearly visible. This technique, used with powerful ground-based instruments like the Canada-France-Hawaii telescope and the Subaru telescope, has been a game-changer. It allowed astronomers to peer deeper into the darkness around Saturn and detect objects down to just a few kilometers in diameter. The discovery of 62 moons announced in May 2023 was all thanks to this method. What's even more incredible is that many of these new moons were actually visible in archival data from years earlier. They had been captured in images, but they were so faint and their paths so uncertain that they were never confirmed. It took years of painstakingly matching objects across different nights of observation to definitively prove they were orbiting Saturn. This reveals a crucial point: Saturn isn't suddenly gaining moons. We're just getting better at reading its 4.5 billion-year-old diary. The ghost of collisions past finding the moons is the how. But understanding the why requires looking at their orbits. When astronomers map the paths of these hundreds of irregular moons, they don't see a random swarm. They see clusters. These moons are grouped into families based on the similarities in their orbits: the Gallic, Inuit, and by far the largest, the Norse group. This clustering is profound. It suggests that many of these tiny moons are not individual objects captured one by one. Instead, they are likely the shattered remnants of a much smaller number of larger moons. The theory is that in the past, Saturn captured a few larger bodies, perhaps a few dozen kilometers across. Over hundreds of millions of years, these parent moons collided with each other or with passing comets, shattering into the swarms of fragments we see today. The Norse group, for example, which contains most of the retrograde moons, is thought to be the result of a single, larger moon that was obliterated in a violent collision sometime in the last 100 million years. This makes Saturn's moon system a kind of forensic crime scene. By studying the orbits of these fragments, scientists can reconstruct the violent events that shaped the system. Each tiny moon is a piece of shrapnel, carrying clues about the cosmic impacts of Saturn's past. This also helps explain why Saturn has so many more moons than Jupiter, which currently has 95 confirmed moons. While Jupiter is more massive, Saturn's greater distance from the Sun gives it a larger region of gravitational dominance, its Hill sphere, making it slightly better at capturing and holding on to passing objects. More importantly, it seems Saturn's system has been shaped by these large-scale breakup events that created vast families of smaller bodies from a few larger ones. Jupiter has its own irregular families, but Saturn's appear to be far more populous, suggesting a particularly violent history. If you're enjoying this journey into the story behind the science, take a moment to subscribe to the channel. We post videos every week that break down the biggest mysteries of the cosmos. And keep watching, because the story of Saturn's moons has a twist that challenges the very idea of what a moon even is. Redefining moon and what comes next. The explosion in Saturn's moon count forces us to ask a rather philosophical question: what actually is a moon? The International Astronomical Union keeps the official tally, but many of these new discoveries are just a few kilometers wide. Saturn's famous rings are also made of countless individual objects, from microscopic dust grains to chunks the size of a house, each in its own orbit. At what point does a large ring particle become a moonlet? And when does a moonlet become a proper moon? There isn't a clear-cut, universally agreed upon definition based on size. This debate highlights that science is an ongoing process of discovery and classification. For now, the distinction is based on whether an object can be individually tracked and have its orbit confirmed over time. But as our telescopes get even more powerful, we will inevitably find even smaller objects, further blurring the line. Researchers estimate there could be many more Saturnian moons just waiting to be found. So, what does the future hold? For one, the moon count for Saturn, and likely for Jupiter, Uranus and Neptune as well, is expected to keep climbing as our detection methods improve. But the focus is shifting from simply counting to characterizing. Scientists want to understand the physical properties of these tiny worlds. Future studies will aim to determine their composition, rotation, and exact shapes, offering more clues about their violent origins. And humanity is planning a return. NASA's Dragonfly mission, a nuclear-powered drone the size of a small car, is set to launch for Saturn's largest moon, Titan. Its launch is currently planned for July 2028. Its goal is to fly through Titan's thick atmosphere and explore its surface, searching for prebiotic chemical processes. While Dragonfly's primary mission is Titan, the technologies and knowledge gained will pave the way for future exploration of this complex system, including missions that could one day fly through the plumes of Enceladus or even land on its icy surface. So, why do we keep finding more moons around Saturn? It's not because the planet is suddenly getting greedy. It's because we are finally learning how to see the empire it built over billions of years. Saturn's immense gravity made it a master at capturing cosmic wanderers. A violent history of collisions shattered those captives into countless smaller fragments. And a revolution in telescope technology has finally allowed us to spot those tiny, faint shards of ice and rock against the blackness of space. The ever-growing number, from a few dozen to 83, to 146 and counting, is more than just a scoreboard. It's a testament to our own curiosity and ingenuity. It's a reminder that even in our own solar system, there are still vast frontiers waiting to be mapped. Saturn's moons show us that a planetary system is not a static collection of objects, but a dynamic, evolving place, full of chaos, beauty, and untold stories. So here's a final thought. If a single planet in our own backyard can hide over 100 worlds in plain sight, what other incredible discoveries are waiting for us out there, just beyond the edge of what we can currently see? Let us know your thoughts in the comments below. And if you enjoyed this journey to the ring planet, please like this video and subscribe for more deep dives into the wonders of our universe.